Let's graph a relation here. So we want to graph this relation. So this is the set of all ordered pairs x, y, so that the y coordinate is less than 2 minus the square of the x coordinate. So maybe just looking at that, it's just kind of a garbly mess of stuff, right? But let's make some sense of this. So this is the set of all the ordered pairs, so that if I had the y coordinate, it would be less than 2 minus the square of the x coordinate. So what would this even look like? If I had all of the points where y is equal to that stuff, we know where those are, don't we? I mean, if I wanted to maybe sketch y equal 2 minus x squared, we know what this looks like, right? If I rearrange these terms, if we would rearrange these terms, I can draw a sketch of this, right? This would be that standard parabola. I would flip it over because of that negative in front. That's that reflection transformation. And then we would move it up 2 units. So if we were going to draw a sketch of this, we have, well, if we were going to draw a sketch of where it's equal, we can draw that, right? It's the standard parabola. We flip it down and then we move it up 2 units. So we're here. What a beautiful parabola. So we know that what this looks like. Okay, well, we're not asked to find where the y values are equal to this number. We're asked to find where the y values are less than this number. So if I'm trying to draw this, we're just kind of setting ourselves up with, here we already knew how to draw where it's equal, but we want to draw where the y value is less. So we know what less means graphically. It means below, right? So I would want, if I'm going to draw this, and I'm just going to rewrite it again, I now want my y values to be below this number. Here's where they're equal. If I wanted my y values to be below that number, we would want them to be underneath there, right? On the graph, we would want it to be below. So I can't have it be equal, and we've seen this before, I think, with our linear inequalities that we had to graph earlier in the semester. But we would use a dashed line or a dashed curve, rather. That'd be more accurate, right? So we can use that little parabola tool on the WebAssign, and we can just put, 1 point on the graph as the vertex of the parabola, and then we should probably choose one of those points. But the big important part, I mean, it's a big important part to get the vertex right and to get another point on the parabola right. But one of the big emphases here is that this is a dashed line. Dashed line, right? So if I'm looking for all of the ordered pairs so that the y coordinate is less than this nice parabola, that means that all my y coordinates have to be in this region, right? If my y value is less than the parabola, right? So we would use that fill button to fill that in. And that's that. Some of these might get a little more complicated, and we can maybe get away with going through a more complicated example right now. So if we did the set of all x, y such that, let's say that y is less than 2 minus x squared, and also y is bigger than maybe x minus 1. So if we wanted to draw this one, we can think about this as a compound inequality, and we should, right? So if we have this, I can rewrite that and I can say y is bigger than x minus 1 and y is less than 2 minus x squared. So if I wanted to rewrite that, we can totally do that, right? So I have to have both of these things true. Our y value has to be bigger than x minus 1, and our y value has to be less than 2 minus x squared. We already took care of this, and we already drew a picture of that right there, right? But let's add this other thing to our picture. So we know what this graph looks like, right? y equal x minus 1. I can draw that down here, right? It would have y-intercept -1, slope is 1. So we would look dashed line, right? I would want to have my y values be larger, right? So my y values have to be larger than this value, so that means that they're going to be up on top of that line, right? So we would want to shade all of this. If it were only this one, that's our solution set, right? And we would shade above the line. But we've got a compound inequality, right? It's not just the one, it's both of these things. So our y value has to be between this line and this parabola. Well, we can just draw that on our graph, right? So we can put our line, and again, it's going to be a dashed line. We're putting that right on top of this other one. Maybe I'll use a different color. So I've got that point there and that point there. And again, this is a dashed line. So if I wanted to be above, y has to be bigger than x minus 1. That means I'm going to be above that line. So we're going to shade above the line. And then that's going to be, you know, everywhere that they intersect. It's going to be in that little region right there. So yeah, we graphed a relation here. The first one we did was just a regular old parabola where we said our y values have to be below the nice parabola, right? So our solutions to that were inside here, that orange shading there. And then we made it a little more difficult where we said, I want the set of all ordered pairs so that the y value is between the line and the parabola. So we shaded them right there. All right, have a wonderful day.